And what we're going to talk about in this presentation is some short description on how we've integrated touch technology into the SAM3 devices, and the steps and kind of the systemic procedures that we've helped you overcome in designing touch technology, which happens to be everywhere. So what we're going to talk about mostly is the left-hand side, what we known as the three-letter acronym within Atmel is called BSW, or buttons, sliders, and wheels. We're not going to talk about the cell phone LCD touch screen technology. Those are dedicated max touch parts that we're not covering. We're talking about the discrete wheels, like on an iPod or touch buttons, more in the industrial space, and how we enable that in our SAM3 microcontrollers. So where are, touch is getting everywhere, although I kind of had a interesting comment from marketing about the fact that they put a touch slider control on a stove, because I've been teaching my daughters for years not to touch the stove, and now we're encouraging them to touch the stove. So now we just have to tell them not to touch the stove where the big round spirally button is. But again, I don't think I need to tell anybody in the audience that everything is going touch. There are some applications where touch isn't suitable, but for a lot of cases, it is. So we've gone from, in terms of the touchscreen technology, we've gone from a resistive touchscreen type of topology to a capacitive touchscreen topology. And what we're doing is we're measuring differences in capacitance. So there are advantages, there are different ways of doing this. You have to apply actually a lot of internal intelligence into the part to figure out that you actually have a definitive touch event. But essentially what's happening in a touch thing is a touchpad that is sitting there away from everything else, not touched by anybody. There's a sampling cap that sits in the circuit, which again, the system is feeding a signal out. It's a kind of a complex spread spectrum signal, and is getting its readings. And as we touch it, we're obviously changing through our own personal electric field the capacitance on that button, and that is definitively determined as a touch event because the capacitance changed, the induced voltage has changed. So, but theory aside, how do we actually implement a touch-enabled microcontroller? So the first step, I'm going to start from the top and work my way down to the hardware. The first thing we provide is called the Atmel QTouch library. This is a pre-compiled linkable library for all our Atmel microcontrollers, and again, for the SAM3, which provides a consistent API function for implementing and detecting events on a button, a slider, which is one of those linear, like a volume control, or a wheel, which again, like the iPod circular. So you write your code to this API, and then you link it against this library, which also contains the configuration APIs for the specific part you're using. And you link it, and you'll implement your touch application, your touch-enabled application. So, of course, in the real world, I mean, it's only software, and it would work perfectly, but we know better. So, just some more things. Again, with a given number of channels of a particular device, with the touch library, you can assign different channels. As you can see, we've got 2 channels as discrete keys. We've taken 3 channels as a slider, and another 3 channels as a wheel. Now each channel, there's kind of a subtle difference between like a single, what's called self-capacitance and mutual capacitance, but for the sake of argument, let's just say that you can increase the sensitivity of the wheel by what's called the number of spokes in that wheel accordingly. You get about 8 bits equivalent of sensitivity on that. And again, as I said, the QTouch supports all of that, and also includes what's called adjacent key suppression, which again, since we're dealing with touchpads that are near each other, again, we're affecting fields. And if you look at the demos, we have some of the touch demos, discrete touch events are indicated by green, but you can see some yellow dots or some brown dots coming up in the LCD feedback screen, which indicate, of course, we have other senses that are picking up that field, change. And we have technology in our libraries that deal with how to sort out what is a real event coming in versus an event that's coming in on a nearby key. So, our design example, this is a SAM3N eval kit that it's kind of new and released, and it has 2 buttons and a slider on the side of it. I sometimes coin these porcupine boards because we tend to drop buttons, sliders, and wheels in the middle of 0.1-inch headers. So there's some careful navigation, but you can get at the things. So I talked about this magic library that solves all of your problems in touch, but really that's how we implement it. But how do you get around to actually knowing how to use this system? Well, with another software tool called QTouch Studio, what you can do is create an actual model. Here we actually have the ultimate 3D picture model of our board sitting in QTouch Studio. And through the use of either a small serial bridge and a smaller application, which I'll get into, you can in real time profile the response of your touch system, check for errors in your layout, and it will automatically, after it's done all that, after you've done through a bunch of calibrations, will automatically generate the API calls into the QTouch library for you. So you don't have to sit there and wad through a bunch of data sheets and figure stuff out. The software does it, and it does it customized to how your hardware's been laid out. This QTouch Studio, again, supports the SAM3N EK and the SAM3S EK. And what the basic concept is it's a kind of a feedback loop. After you get your board done, we also supply a tiny little program that runs on the microcontroller, which provides this real-time application support, which gives you the feedback back into QTouch Studio, which tells you, again, your performance parameters and how well your design is. And again, you can tell it to generate your API calls from those design parameters. In the case of where you have a SAM3 microcontroller that doesn't have built-in USB, there's a little bridge board that hooks between the SPI port and bridges out to a USB connection. So we've come down, we've got this nice little software library that allows you to use these buttons. We now have this QTouch Studio that you can in real time profile and get information on how good your design is. It'll tell you how bad your noise levels are or how good your noise levels are. It'll again automatically generate the initialization code for the QTouch library. But we're missing that last layer, and that's the hardware design. What we've done with Altium, and this is valid for Altium Designer 9 and 10, is we have a built-in interactive studio plugin that plugs into Altium that allows you to pick, according to your design, specific button, sliders, or wheel elements. And we have built-in pre-qualified PCB layouts, footprints for these devices. And you can work with pull-up menus to design the size and the resolution and the spacing of all the design rules around your hardware design all automatically. So the level of success is much higher because you're now dealing with an interactive, more intelligent design system in Altium Designer that will help you design a really effective touchscreen interface system. So we have now filled all 3 levels. Okay, that's as I was saying. So there is a intelligent, we have some standard footprints, but there's some intelligent XML generation going on in scripts that allows you to, again, as I said, as you're laying out the QTouch, as you're laying out your QTouch pads and wheels, you can interact with this studio and it will modify the footprints for you inside Altium Designer. So now we've covered all 3 levels. We've gone from the top, from the QTouch library, which allows you just simple API calls to actually just use them as normal simple buttons or a slider, We've gone down a level using QTouch Studio to help you qualify your hardware design, and at the bottom layer where the hardware designers are going to start with is Altium Designer, is the QTouch plugin for Altium Designer, which will help you from the ground up almost make a completely foolproof touch interface. Because again, these are qualified layouts and design rules designed to work with the QTouch system.